computer. You can start.
Okay. Hello, guys. This is my second presentation on the same topic, using machine learning in image search. It's similar to what we have a few months ago, but we made some progress, including in deploying the models and more in our mental state, what we think about it. So first of all, I want to just refresh what it is. My company called Get Archive. In 2016, we started developing the platform for digital publishing, mostly targeted to archives and museums. It didn't go well, but when we developed it, so we had basically very small and very low traction among the clients, and none of them were American clients, mostly were Europeans. So we faced kind of a challenging pivot. And while developing this platform, we developed the demo, which was pickrel.com, the website where we published the media of what we collected. And by doing demo, we started collecting public domain images from the same museums to showcase how it's going to work. And suddenly we found attraction among media consumers, not media providers. So that was our pivot, and the company is growing since. A little bit about myself. I have previously created the marketing business, producing mortgage leads for brokers and credit leads for financial services. I've been in the United States more than 20 years. This is my kind of a second project that I was able to launch to the stage when it generates money. Hopefully this one is much bigger than the first one. So right now we have almost 29 million images, add in about million months, and I think we can add faster. My goal is to get closer to 50 million images this year. So when we started to collect images from different sources, we faced very diverse metadata. And basically, search didn't work. Classical search didn't work in that because some metadata was in English, some in German, some was targeted on certain topics and another topics. So it was very bad database from the point of view of taxonomy. So all the labels and tags were very, very diverse. Nothing could be found systematically. Sometimes it worked if the person from the same background as the media that we got collected from somewhere, but most time it didn't. So we started to augment metadata and tweaking search to get it more agnostic, like user and language agnostic. Our first take was what would I call GPT 1.7 or GPT 2.0. Was 2020. It was Google multi-language model that was trained on a huge corpus of documents on different languages. And according to documentation, it was 12 languages. But as always with big language models, the side effect was the ability of this model to understand languages that it wasn't really having as a sources, like Armenian language was suddenly pretty good in understanding. Probably because it was both English and Hebrew there, so sometimes something in Armenian as a very old language probably recognized pretty well. It was our first step. The second step was to augment the tabulated data. So we used Clip network that Facebook developed at that time, at 2017, or later, 2020, probably, to label. So Clip works the following way. You feed Clip with the set of custom labels. In our case, it was about 5,000 of them. And then it calculates probability of each label in each image. So this vector space was about 5,000 dimensions. And we also used Clip to create the pairs of visually similar images using the top 4 members of the vector to create pairs. And that what is one time in production, and it increased our user satisfaction a lot, like very, very much. It created completely different user experience, much more advanced than you can expect from the model, which is only operates with about like 5,000 vectors. And now we sort of finished this part. We combined human metadata, Clip and Bleep. Bleep is another network developed a year later by Salesforce. We generate very generic image description captions. So it doesn't know what's on image, but it more or less generates what like person who has no idea what's on image sees. So instead of a Romanov family, it says 4 women sitting next to the table. And this is basically very good, combining with the human metadata that was already there and the Clip labels that were sometimes very relevant to what it found. All this,
Boris,
yeah,
sorry. Clip is an abbreviation, right? So, oh, it says
yeah,
here constructive
yeah, yeah,
language image, and
yeah.
Bleep is
So,
bootstrapping. Okay.
yeah. So all those 3 greatly improved search experience. Clip also generated pair of a visually similar in the vector space. Very primitive, but with the result it was very good. Again, the Bleep greatly increased chances of a person putting something in the search bar and getting result. So Bleep basically perfect for stock imagery. When you look for something like close-up of a person or close-up of a cat or sunset, this sort of stuff is basically generic descriptions that Bleep generates that matches average no idea person. But Clip is kind of a different. I will showcase later. And back to semantic search. Semantic search was used as a fallback method when we could find something with tabulated database, which is now case is MongoDB plus Elasticsearch, and multiplied it generally by 10. So, and it also reduced an ability to search in any language without even backend translation. It was able to pull relevant images from the database if you type in Russian, and then we tweaked it a little bit, and when we can translate to English, we translate to English, but it pulls metadata in French, Japanese, whatever. So we don't really touch the metadata itself on a media. We tweak the search request on the backend so it get more kind of fruitful, but it could work even without any tweaks, and it did work. So we made here huge 10 times increase in search relevance and number of searches that matching any average search request. And then we came to another method, which is labeling using Facebook Clip. We started with developing our own model and our own data set, and you can see some traces of that. We have data sets like 35,000 of steam locomotives or 20,000 of the 1920s cars or even 1910s early automobiles, stuff like that. But it was very time consuming. We developed about 600 of the sets like that, and then we gave up. With pre-trained Facebook model, we just fed it with around 5,000 labels, and we basically get 10 times more result in a 10 times shorter time span. This is the short our technology stack. So we use NVIDIA GPU machine to label and to do other operations with images, and then we deploy it in a standard setup, which is Elasticsearch, MongoDB, and the fallback method Google AI, which is frankly is not quite necessary now, but it's still there. Why not? So this is how our backend looks like. That's metadata that we have that we use to rank images according to the relevance to any given search. The first, we have human-generated metadata that comes with the image. In this case, it is French metadata for Marie Antoinette. This is bleep caption, the generic description that the Salesforce bleep generates. And now we're running all images against another 3 or 4 similar networks to generate slightly different captions. In some cases, they will deliver new information. Let's say it's the Philadelphia Center, Chinatown, and the Chinatown gates. Some network was just deliver cars and the city, street, and some will say Chinatown. So that will deliver more relevant data about each image, more since some descriptions will be repeating in several outputs, then we can make sure and be sure that this is the most relevant and we can rank it accordingly. And if in the search string we have this semantic piece, then we can basically deliver much more relevant results if the same result is found by several machine image recognition models. So the next part is our 5,000 labels ranked the green part. It's all, by the way, in the free use in MIT license, so it's completely legal what we did. So you see the label and the probability of it. In the top is what our labels look like. For the images that were ever downloaded, we also call Google API. We call 2 Google APIs, one called Vision and the second is Web Vision. Vision is similar to what we have, with about 20,000 labels, not 5 like we. And Web Vision is basically how Google search works. That's a result of probably something like parsing or entity extraction from the HTML surrounding the image. So not only you can find label like a castle, but Neuschwanstein castle, very specific. So for images, again, that are in some demand, we have the blue labels, which comes from Google, and then we use AI human loop to verify them. So number of 2 on a blue one, which comes before the label, is how many votes we have for each of the labels. And we use this as a ranking method as well. Everything is sent to Elasticsearch with certain weights. It's a classical stuff. Every search engine does it. So this is how it operates right now. Now I want to tell you what we are thinking about to do this year. So using GPT-4, it is possible not only generate pieces of metadata like labels or generate captions like Bleep does, but actually combining them, you can generate captions that are niche specific. And if you have, let's say, museum customers, which we hope to finally get, even if we failed the first time, you can create an API which will be sending back, which will be receiving an image or some pieces of metadata, and using fine-tuning or even embedding, it can send back very museum-relevant caption, not just generic, which is right now. This is one way. I'm not sure that there is a demand for that, which is paid, so we're not kind of doing any acceleration in this project, just as it goes. Probably we will, anyway, we will start generate those for search engine optimization. That is our main method of getting new users. And as a side effect, we might develop API which will be capable to generate captions which are market specific. Like for car dealers, it would be car parts. For museums, it would be museum-like description. And for French museums, it will be museum-like descriptions in French. This is one way to go. Again, I'm not sure that we go there because I don't know if there is money there. From the other hand, we have our own user database. We have about 20,000 unique users a day and about 200 new signups a day, which is pretty awesome. And we can see what people are searching for. And actually, we can gather their searching history. And if we gather their searching history, we understand what this user is about, and we can adjust ranking of the search results and what we show on a screen to better fit this particular user. In a sense, it will be reviving I feel lucky button on Google, but really understanding I, feel, and lucky. So maybe this way. So if you mix them both, you get also capability to, if you have enough power, you can even rename images on the fly to match the user profile. So you can rename image for English speaker school pupil and for French academician. It is theoretically possible. Again, whether or not it is visible from the prospects of investments and the costs versus revenues, I don't know, but this is possible to do. And the next slide is explaining the second concept a little bit. Different people and different models see absolutely different things in images. They label them differently and they understand them differently. And if you look at the image of any Library of Congress which has historical value, some people see some landscape, some people see horticultural cherry trees, and some people see President Taft standing on a Pullman car and making a speech, and some people don't see anything of that, but they care about the building behind it, which is the current Congress building on Pennsylvania Avenue or White House, whatever. So different people see different stuff, different models see different stuff. And for different people using different models or the same model with some adjustment of a prompt or input data or fine tuning, you can generate different textual descriptions. And if you do it on the fly, theoretically, you can even reshuffle your index because it is sort of fit to semantic space of this particular user, which again can be calculated based on the search request or the history of a user journey on a website, including some parameters that are not quite obvious. Basically, different people are different over the time. So today I'm searching for something, tomorrow I'm searching for something else. But the vector which connects the first and the previous one, again, can be calculated. So this is a huge mathematical opportunity here, not enough power as of yet, but probably going to be feasible in a year or two. So truly custom search experience, including truly custom renaming of a media, is possible now. And basically the idea is to put any media object into the same vector space. You can use same vector space for images, people, and article. So basically, image is not that different from Wikipedia article. It just article has some vector parts that image doesn't, and vice versa. Article doesn't have a color or stuff like that, or user doesn't have a publishing date. But if you kind of remove certain parts of the vector, you essentially do slices of this space that are applicable to all of them. This may be another great opportunity to produce the results that cannot be produced right now. So this concludes my presentation, and I can demonstrate BigReal if you wish. Let me just where you do it. Yep. Okay, so this is our backend. You can type.
Hold on. We still see the slide.
You still see the slide. Okay, let me just do the presentation right here in this screen, okay?
Mm-hmm.
Okay, so this is the front end. These are collections. These are popular tags. We call them topics. Nothing like labels is visible there, but it powers the similarity sets. So you can basically go to any image and you can see the pairs which are generated using these 4-member vectors in 5,000 dimensions. And this is pretty awesome because it even looks the same. Then you have the result of a just textual search. In this case, we have plenty of this in German, of this title description. And if you send it to our search backend, it produces images from the same book, basically, because that's how librarians are. They're lazy. They name all the pages in the book in a very similar manner, which is very good for us because it can produce very, very relevant results. And here on the bottom, you see mixed bag. This is like embryonic vector slice. This is similar images within one of the tags. So this is like fake vector database. It is not dynamic. Everything that you see here is basically, but this one is static. You can't really reshuffle those pairs. You cannot really reshuffle anything here. It just comes as is, calculated before. And nevertheless, it delivers great experience for the people who are looking for relevant stuff. Most of the customers are historians, academia, producers of the movies, documentaries, and fiction. And we have plenty of people just saying, I love you so much, your website make me cry. Literally, we had you emails like that. And then they complain that they need money to access the full features, of course. But uh, anyway, this approach, which includes vector similarity and basically vector search, very primitive, uh, delivers much more and sometimes much better than the classical search engine backends like Google's. And it allows you to do very, very cool stuff, like red dress delivers you everything in red dress. But then you can pick dates here, which you cannot pick on Google. That's another kind of a space that you can cut. Or it's completely different set. Or you can only choose paintings. Or you can do something very cool, which is literally impossible in Google. You can do Marie Antoinette, which is kind of okay. Google can do it. But then you can add green dress here, which will probably produce nothing. And here you have Marie Antoinette in a green dress. You can play with that and you can deliver French car racers with mustache. Basically, it will deliver you something. And here is no green dress, but green background. So that's how noisy it is, but it is better than nothing. So now I would like to hear some questions if you have them. What should I do, Lev?
First of all, thank you. It was a very good presentation. I'm
Uh-huh.
confused. You always say the word vector
Uh-huh.
and search, but in this particular case, what you're showing on PicReal,
Mm-hmm.
what is the vector? How big is the vector? Is vector consist of numbers, or it consists of words, or like what is it?
Okay, here is the background. So it's the Hebrew letter for the fire. Um, and in this case, vector is absent. We only have tags and we have Google labels. There is no vector representation here. And if you go on the front end, you can see this. This is the first letter in the search. So it's easy to find.
By the way,
So
why there
you
is no vector? Because it fall back on Google API?
No, because it was labeled as a manuscript, and we didn't do it for the manuscripts. We only did it for the like subject images. So we didn't send this particular one to the clip, which is our vector space. Um, so this one only has a block related, which is semantic function from the title. But if you Yeah, here is nice products which we're working on now. So you can buy a mug with this nice Hebrew manuscript. But if you go anywhere else, such as, I don't know, let's go here. That's a manuscript too, but I think
Hold
what's
on, we
going on
still we
here?
still
Well,
see the same picture.
yeah, and I don't understand why. What's going on? Mm, okay.
Are you sharing the whole
Yeah.
screen or just one window?
Okay. Yeah, my fault. Okay, so going back to, yeah, I switched the screen and everything I told kind of lost in vain. So let me do it one more time. So this is the Hebrew manuscript letter I was talking about. It was never sent to Clip, to Facebook Clip. So we only have related box here. We don't have similar, visually similar ones, because this one is unknown to our vector space. But if we click to anything else, let's say we click to this drinking horn. Probably we sent it to Clip. Yeah, we sent it. So we sent it to Clip.
How do you know it was sent to Clip?
Because I see this similar box, which was absent in the Hebrew case.
Oh, okay.
Okay, so we sent it to Clip, and it found something, and I can show you what did it found. What did it find? I can go on my backend and just try to find this image. Yeah, here you go. So it was sent to Clip, and it was found as a weapon, horn, musical instrument, and 16th century. Anything of that is bullshit, right? It's like not really good. But because other horns were sent to the same, oh, you can see it again. 1 second. Yeah, I always, okay. Here, I'm repeating myself now. So this is the backend, and this is the horn. This is a human text that came with it. Actually, we derived them as entities or whatever parsing method. And this is the labels. Weapon, horn, musical instrument, 16th century. It's all garbage, it's all bullshit. But since all the horns from the similar sets were sent to the same model, it delivers very coherent results for them. And that's why it's only 4 here. So we took all of them and we showing similar, similar, which you can look at this now in the same space.
So the vector consists of 4 labels?
Yeah, this is a very short one. And this is where we can actually improve it a bit. Our next vector probably going to be a very long one. We're going to tokenize the title using entity extraction. Probably going to tokenize the summary using the same method. Probably we're even going to tokenize the collection title and name, which we put it in manually. And we're definitely going to tokenize the human tags, and we're definitely going to tokenize the Google labels if we have them, if anyone, anytime downloaded this. We're going to tokenize the blip caption. We're going to tokenize the clip labels, and we're going to tokenize another 3 captions that we're about to receive. And we're also going to tokenize the period, the date, and if we have geographic location, the coordinates, right? So what we're going to have at the end is very long vector, which is absolutely useless now. But if we build something like pending next to our current Elasticsearch vector database like Vespa, and we cannot use third party because I was calculating what we will have as a bill according to your numbers. And the number of vectors in this is actually not the number of media, but number of media plus number of labels plus number of tags plus number of entities. This is like 10 times more, optimistically speaking. So we're going to have the bill, which is like 6 figures a month, which is not, or 5 figures probably, which is not quite good for a startup like us. So we're probably just going to deploy it ourselves. I'm working with the finding the right people for that right now. And if we do that, instead of a static set of a similar ones, we will have a switch here, uh, which will be probably 16 positions or whatever positions we have in the vector. And by switching it, you making a slice of a space, removing, let's say, date or geographic location, or removing the color, or removing the metal, or removing the horn, or removing the gray background. So each switch in this going to produce different set of similar results from completely different points of view. And I can figure out few use for that. Some users,
Hold on.
right,
I don't understand
right,
something. So you have
right,
multiple labels, which you use different methods to get those labels. And you
right.
say, well, we can remove one of those labels, whatever, to get a slice. But why you
Uh-huh.
need to remove it completely? Maybe you need just to change the weight. Maybe each of those
Yeah,
labels should
yeah.
come with the weight.
Very much possible that removing is not a good way. The weight is much better, and that's not going to be a switch, but some sort of a control, which is probably even 2D, like a circle that you move your mouse in, and changing the flavor of your similarity angle, I would say, in this space. Uh, yeah, and all this can be even expanded to the text, which is another business opportunity, because right now uh, we have 3 tabs, which is like everything. Then we have images, and then we have texts. Um, but text actually scans, right? But we can just remove one tab or like add another tab, which will say like knowledge, and we will pull Wikipedia articles about this, but based on a user history, or based on a previous image, or based on whatever vector representation of whatever we have in this case, delivering custom search. For the teenage school girl, it will deliver one set of knowledge, and for the academician who is looking for archaeological finding, it will deliver completely different set of relevant uh, articles and media. So this is how search may mutate pretty soon if we have enough computer power. Uh, did I did I answer the question?
Yes. This is very exciting. Like
Uh-huh.
looking into the future. I'm
Uh-huh.
so so interested to see like when it will
Yeah.
actually start
And
working.
and remember, we had a chat when 2 months ago, right?
Yeah.
So we lived through the generative hype, right? Which is
Hmm.
kind of slowing down now. And imagine generative possibilities here too.
Right.
So yeah. So by the way, we had to close search results once we deployed Bleep, because it literally started produce like data set um, stuff. Yellow car, for instance, and it starts to produce in data sets for free, and the people started coming to us, and they and use it for generative purposes. So we
Yeah.
get huge spike in traffic, And when we closed it, so now we only give 2 pages of that for non-upgraded users. For upgraded, we still give everything. They don't even download it, full resolution images. They only need this thumbnails. Okay, if they pay little money, like 84 a year or 25 a month, let them do experiments with that. I don't care. So 400 pages of the yellow cars. This is like more than enough for any generative purpose. See, or you can use like a green head. I have no idea if we have enough green heads. I'm just typing out of blue. Yeah, we have them. Okay, or we can type now man with mustache. Mustache can be typed in 2 ways, mustache and mustache. So I don't know. Yeah, you can have man in mustache more. You use this
But this
stuff.
actually makes you another business, which is you become a data provider for machine learning teams, helping them
Um,
to train their models. I mean, data is the king,
Lev,
and yo,
Lev, if you want, please take over this because I'm basically the product manager. I'm perfect product manager. As you can see, I developed very useful user interface and I know
amazing.
my user, right? But I have no idea. Once I'm starting talking in a B2B, something is really wrong with me. I cannot convince them to do anything. Everyone just was like, and they need to be presented with some formal, like, okay, go here and they pay here and you get this. But
No,
I'm
no, no,
kind of
but
lost. Like,
those people who scrape your website, right,
right.
with
Uh-huh.
specific keywords, you know who these people are, right? You can talk to them.
Yes, I had couple instances. They came, they quote. I sent them a quote. They never came back because everything in this volume comes to about $10,000. So $10,000 for them, for people who approached me, is probably too much, and they are savvy enough not to pay and just scrape somebody else, stuff like that. So I need corporate people, and what I have in mind, they have their own corporate image sets or databases of a knowledge data. And if I can, if I have someone, I can actually create a box, which will be not even in a cloud or like secure cloud solution, which I will sell as a really secure, which is nonsense. But
So
again,
you can index their
they buy.
data and make custom search.
Right.
Yeah.
I can create completely different sets of indexes on their images and in about a couple months on their textual data as well. So this is completely new way of indexing data, which was not in place before machine learning. And we are about to adopt vector databases that are currently booming because of the machine learning to this. So it would be probably even bigger impact for search than just GPT. And even GPT is a huge impact. You can do this.
Right.
Uh, but with vector databases, you will be able to real time change the content of this. Now I made it infinite, like infinite. So you can just scroll and scroll again, but you cannot change the angle of this. But with vector databases, it is completely possible. And you say, hey, this is something not really relevant. I only want the relevant images with letters on them, like big letters. Bam. And you change everything. Or only British cartoons. I want French cartoons. Bam. And you get only British cartoons. So this is about to become possible.
Yeah. Okay.
Mhm,
Boris, thank you very much. We were a long time online, so it's probably time to
mhm.
finish. Thank
Okay.
you. I'll
Thank you.
stop recording. What?
No, it's a great presentation, definitely. You can stop recording.